Hello everyone, welcome to this video where I will show you how to make an inverter system of your preferred capacity using EGS002 model. Now on this video I will show you the introduction. I will introduce you to the EGS002 model, the working principle and navigations. Now the EGS002 model is an inverter card system which is used to generate PWM signal inverter using this EGS010 microcontroller, and it has two MOSFET driver on it and an operational amplifier for current sensing. Now this module has 17 pin. As you can see, it has 17 pin on it. So I will take you through the 17 pin and their functions and how to connect them, and some things that need to be adjusted from the circuit diagram I will show you on this video. And the LED you've seen on this module, it has several functions. The LED here has several functions, so I will also tell you more about the functions of the LED. Now, as I've said, the IC has 17 pin, so I'm going to take you through the 17 pins and their function. Now, the pin 1 is the current feedback, that is the I feedback, IFB, that is the current feedback. Now, the current feedback is mostly connected on the negative pin on the battery, that is after the fuse, to sense if the MOSFET is draining current more than the switching. So it will sense to the I feedback, and the I feedback will send to the microcontroller to tell the microcontroller that there is an overload on this inverter. So in we discussed the MOSFET sizing on the previous videos. You can check my channel for MOSFET sizing. You can check your MOSFET sizing to avoid overcurrent protection or overcurrent on this IC. Now the pin 2 is the ground, which is going to the negative directly. Then pin 3 is the ILO, that is the low side gate driver. The low side gate driver. And the pin 4 is the ground. And pin 5 is VS1. The right bridge high side floating supply return. That is the VS1. Then the 1HO is the high side gate driver. All these ones too I will show you on the circuit diagram. Then pin 7 also goes to ground. Then pin 8 is the 2LO, that is the left bridge low side gate driver. Then the VS2 is the left bridge high side floating return. Then 2HO is the left bridge high side gate driver output. Please, I would want you to have these drivers in mind as I go through the circuit diagram also. Then the pin 11 we equally have a ground there, and the pin 12 we have a 12 volt supply. So on this, if you are making a 12 volt system, if it is a 12 volt system, you don't need a 12 volt step down your battery. Your 12 volt battery can connect to it directly. The maximum input on this IC that this card can work on is 15 volt. Please let it not exceed 15 volt. The maximum input voltage of this card is 15, and once this card exceeds 15 volt, it will shut down the MOSFET driver, and you will have to replace it, and getting another one will be very difficult. So it will render the card completely useless. So please, you need to be very careful about that. So if you are using a 12 volt system, if you want to design for a 12 volt system, you only need a 5 volt regulator. You only need a 5 volt regulator. So the input will stay on the pin 12, then the ground on the pin 13, and the output of the 5 volt regulator will go on the pin 14. That is the 5 volt supply. That is for the output of the 5 volt regulator. So this 5 volt supply is responsible for powering the microcontroller. on that board. So you need to make sure that the 5 volt we're giving to that controller is a smooth 5 volt and a very clean 5 volt, and let it not be more than 5 volt, please. And if possible, try and test your regulator before mounting it. Now the pin 15 is the voltage feedback. The AC feedback is referring to the EGS002 data for specific function and circuit. This one is responsible for feedback so that it can be able to maintain a 220 volt output on your inverter. And also I'll tell you some navigations on that feedback circuit on the circuit diagram. Then the temperature feedback is responsible for temperature sensing. It will be mounted on your L2 on the low side of the switching MOSFET 2, which is always heating on your inverter. So you mount it there so that it will sense the temperature of the inverter at a time, and so it can be able to turn on the fan while working. Then pin 17 is the fan control. It's responsible for turning on the transistor that will be responsible for switching the fan on when the temperature is over 45 degrees Celsius. Now the following are LCD's display interface. As you can see, they are here below. I will also show you the image of the LCD below. Now on the IC, behind the IC, there is you will see J1, J5, J2, J6, J3, J7, J4, J8 and J9. All these ones are jumpers. I will have all these ones are jumpers. Now the J1, please follow me carefully. You see the settings and the description. If the J1 is short, that means when you loop the J1, it selects the AC output frequency to 60 Hertz. Yes. Then when J5 is short, it selects the AC output frequency to 50 Hertz. So please make sure that if J1 is short, J5 is open. And if J5 is short, J1 should be open, please, to avoid damage on the IC. Then the second one is the soft start. That is J2 and J6. If J2 is short, it enables 3 seconds soft start. The IC will take 3 seconds to start fully. While if J6 is short, the soft start is disabled. So once you connect, it means that when you turn on the inverter, automatically it will turn on from 220. There's no soft start, it will just on instantly. So if J2 is short, J6 should be open, and if J6 is short, J2 should be open. Now we have the dead time. The dead time, please, I will advise you ignore this pin 3, ignore this designator 3 and 4. 3 and 4. Then the designator 5, here is the LED. That is on the screen display. If you want the screen light to be always on, you can short circuit, you can short pin 9 to make sure that the light is on when you connect the LED. Then if you open it, the LED will be off, but the screen will still be work. The only thing that will not show the LED, the display light, the backlight of the LED. Now the driver board jumper J5, J2 and JP7 and JP8 are shorted as default setting, corresponding to 50 Hz and soft start. So the board always comes with a default setting, which is a 50 Hz and also a soft start on the inverter. So and the dead time is 3 nanoseconds. That shows the time which the inverter will shut down. The time which this IC can shut down. So whenever when we'll be implementing the charging system of this inverter, we'll make use of this DT0 and DT1. That is when the IC will shut down and when it will start, because it will need this while setting the charging system on this particular inverter system using EGS002 model. Now, warning: the jumper of the same function cannot be executed at the same time. For example, J1 and J5. I've told you this earlier, so please you pay careful attention to this. Now, these are the LED warning. You can see the red LED on the card. So there is a warning for every time it blinks. Now the EGS driver provides LED warning indication function. User can determine problem according to the following. Now, if the all pins are connected correctly, the LED will be on standby when the inverter is on. So once you see the LED overcurrent now, it will blink twice, off for 2 seconds, and blink twice again. It will continue repeating. Then for over voltage, that is when the voltage you supply to the card is over. That is over 15 volt. It will blink 3 times and off for 2 seconds and blink for 3 times and continuously. Then if your battery is low, that is if it is for 12 volt, if your battery is low, it will blink 4 times and off for 2 times and keep recycling. Then if the temperature is high, it will blink 5 times and off for 2 seconds and keep recycling. Please, I would want you to pay attention. Once you see this card making any of these errors, please pay careful attention. If not, it might affect your card. So please, you need to pay careful attention on these cards when using them to avoid any damage or any other thing. Now, this is a typical circuit of a transformer-based inverter using the EGS002 module. If you check the above, you see a 5-volt regulator, and you can see the feedback using a four leg diode. You can use one and 4007 for the MOSFET diode, and the parallel resistors you seen there are 100k on the feedback. I'm talking of the feedback from the transformer. You can see all of them there are 100k. Then the variable resistor there is 200k advisable. 200k advisable. Then the capacitor there is 4.7 UF. Now if you check, all the parameters here are as connected as I have told you. You can see the 5 volt is supplied, the 5 volt regulator is supplied to the 5 volt of the module. Now from my left you can see pin 1 to pin 17 as I've explained below. So on the switching of the MOSFET, the first MOSFET on my the top left is H2. Then the second one on my top right is H1. Then the down on my left is L2, and the down on my right is L1. So the L2 heat sink is where you are going to mount your temperature sensor to sense it. So the diode on the gate of each MOSFET, you should try and put it so that for reverse current and easy discharge. So if there is on the output also, you will need this capacitor 2.2 UF for smoothing the output. So you adjust the output of the feedback. So it's advisable you turn your potentiometer to ground while adjusting it gradually. And please, you need to pay attention. Then on this transistor that controls the fan, you can use any N-channel transistor. Any N-channel transistor will work, and a 12-volt fan. So for example, you are using it, you want to use for 24-volt system. All you need to do is to get a step-down module. That is a switch mode power supply, or any step-down module that can step down 24 volt to 12 volt. Then you will feed it to this system, this 12-volt regulator. Then if you are making for 48 volt system, you get a module that can step it down to 12-volt system. So please, I would want you to like and share this video. If there is any question, you can drop your comment below. Thank you. We'll see you on the next video.